Dear students, I hope all of you have gone through the topics covered in the last session. That is about fluid, its classification properties. Today, we move on to the next one, that is fluid pressure. Okay, I think you all have heard about what pressure is. And in general terms, we can define the pressure as a normal force exerted by a fluid per unit area. What is that? We can say that the force exerted by surrounding fluid on an area will be perpendicular to the surface of that area. So we will uh, discuss one example, because if we uh, put some objects into liquids, or if something goes or something immersed into the liquids, naturally that liquid will exert pressure on that object. Mm. It's usually this divers. You have heard about divers. They go deep into sea or rivers and all. When they go deeper into that, they feel some uneasiness just because of the force or pressure acting on them. So pressure can be defined as a force exerted by molecules of fluid on the objects immersed in it. So there's an equation: pressure P is equal to force F by area. Its unit is Newton per square meter, or its another name is Pascal. Then megapascal, kilopascal, depending on the values, we can give several units. And another one is bar. You have heard of atmospheric pressure is usually expressed in bars. 1 bar is equal to 10 raised to 5 Pascal or 10 raised to 5 Newton per square meter. Okay, next thing is static fluid. It has no shear force, only normal force is present. Static means it does not move. It does not have any shear force. That means the molecules will not shear apart, or molecules will not flow, or the liquid itself will not flow. When the molecules move, there will be some shear force. Otherwise, no shear force, only normal force will be present. Then pressure is of two types. First one is static pressure. When the force in a system under pressure is constant or it is not varying, the pressure is said to be static pressure. If the force is varying, then the pressure is said to be dynamic. Static means does not move. Dynamic means it moves. Then another term you have to study, that is pressure head. Pressure head, the intensity of pressure at any point in a liquid contained in a vessel is proportional to its depth from the free surface of liquid, and this height is known as pressure head. Okay, if you want to measure the pressure at a point in a liquid, then we have to measure the distance of that point from the free surface of the liquid. That distance is known as pressure head, and if you want to get the pressure, intensity of pressure, we have to multiply that with its density and acceleration together. That is, pressure P is equal to rho gh, where h is the pressure head. So pressure head is a proportional value of the intensity of pressure. We can say pressure being a function of h, that is sometimes expressed in terms of height of fluid column. That height of fluid column is called head of pressure or pressure head. Okay. Next one is another important law. It is concerned with fluid pressure. We all have learned about Pascal's law. I think you have learned it in school itself. Anyway, we'll discuss it now. Pascal's law. What is Pascal's law? It states that the pressure at a point is equal in all directions in a static fluid, or pressure applied at a point is equally distributed in all directions if pressure changes due to the weight of the fluid can be neglected. That means the pressure applied at a point is equally distributed in all directions if we neglect the pressure change due to the weight of the fluid. For example, if we if you pour some liquid in a container, in a plastic container or something like flexible container, whatever it is, if you apply pressure at a force or pressure at a point, naturally the pressure will be distributed equally in all directions. That is what Pascal's law says. So here we can see one diagram, it's an image. It shows the application of fluid, Pascal's law. We can see that two limbs are there. First one is a smaller one having a smaller diameter. If we exert a force in that piston, we can see that a larger piston on the right side or right limb. If you apply force in the left piston, that can cause the lifting of the right piston. Even if it is larger in diameter, the force by area, that is pressure, will be same, will be applied to the larger piston. If you, that is F by A is in the inlet or the left side, will be equal to F by A in the outlet. That means using a small force we can lift a larger weight. That is the application of Pascal's law. I think you got it. You can see a small piston, using a small piston we can raise a larger load. This is because of the Pascal's law. The pressure will be equal in both sides. Okay, got it. That means if you give a small force on a small area, that will be, if the area is larger on the output side, naturally the force will be more, so we can lift the larger load. Next one is atmospheric pressure. We all have heard about atmospheric pressure, its value and all. So what is atmospheric pressure? It is a pressure exerted by the envelope of air on their surface, pressure exerted by the envelope of air on their surface, or by the weight of air exerted on their surface. So standard atmospheric pressure, it is 1.01325 bar or into 10 raised to 1.01325 by 5 into 10 raised to 5 Newton per square meter, or 101.3 kilonewton per square meter at 15 degree centigrade. That is atmospheric pressure. What it means? That means 1 square meter column of air would weigh about 101.3 kilonewton. That is 101.3 kilonewton per square meter, means 1 square meter of air weighs, the weight of air will be 101.3 kilonewton. Okay. Measurement of atmospheric pressure is usually done by barometer. Next one is how to measure the pressure on a fluid. There are two different systems to measure. The pressure is measured above the absolute zero or complete vacuum, it is called absolute pressure. Another way to measure pressure on a fluid is by measuring it above atmospheric pressure, and it is called gauge pressure. So we have to study three terms: absolute pressure, gauge pressure and vacuum pressure. Okay, what is absolute pressure? It is defined as a pressure which is measured with reference to absolute vacuum pressure. Absolute vacuum means absolute zero, no pressure at all. There won't be any molecular momentum. That is called absolute pressure. No pressure at all, zero pressure. That is absolute pressure. Next one is gauge pressure. Gauge pressure is defined as the pressure measured above atmospheric pressure. So atmospheric pressure is taken as the datum. So we will assign the value of 0 to atmospheric pressure. Atmospheric pressure on the scale of equipment is marked as 0. So even if the scale shows 0 reading, that is assumed as atmospheric pressure. So atmospheric pressure we know it is 1 bar. 1 bar pressure is taken as 0 in the scale. So gauge pressure is considered as pressure above atmospheric pressure. Now next one is vacuum pressure. That is pressure measured below atmospheric pressure is known as vacuum pressure. Vacuum pressure is also known as negative pressure. Negative means below atmospheric pressure. It does not mean that no pressure is there. Vacuum means usually vacuum we are referring it to as emptiness. But here it is not like that. Vacuum means some pressure is there, but its value will be below atmospheric pressure. So it is also known as negative pressure. Okay. Now, relationship between absolute, gauge and vacuum pressure. So mathematically we can represent as absolute pressure is equal to atmospheric pressure plus gauge pressure, and vacuum pressure is equal to atmospheric pressure minus absolute pressure, because atmospheric pressure is taken as the datum, that is why. So when we calculate vacuum pressure, that is atmospheric pressure minus absolute pressure. So absolute pressure will be greater than atmospheric pressure, so we will get a negative value. So vacuum pressure is always represented by negative values. Okay, atmosphere in terms of mercury column, the atmospheric pressure head is 760 mm of mercury or 10.33 meters of water, that we have learned in school itself, right? Now we can see the graph or a picture. Okay, you can see that gauge pressure, atmospheric pressure is taken as the datum. Above that gauge pressure, vacuum pressure comes below that. Absolute zero, you have to see that the bottommost one is absolute zero pressure. So the total is absolute pressure, that is atmospheric pressure plus gauge pressure, or atmospheric pressure minus vacuum pressure, that is absolute pressure. Two values you have seen that absolute pressure, there are two values. One is atmospheric pressure minus vacuum pressure, and another one is atmospheric pressure plus gauge pressure. Okay.